In this example, we're going to look at how to create confidence intervals using SPSS, using data from the 2012 General Social Survey. And so if we want to create a confidence interval, let's say that we wanted to do it for the variable education, we would just go to Analyze, and then Descriptive Statistics, and Explore. And now we need to pick a variable for our dependent variable. And so we use education as our dependent variable. And we're just going to move it over here to where it says dependent list. And then if we click on statistics, we can set the confidence level. And so by default, it's 95%. But if we wanted to create, for example, 99% confidence interval, we can just change this number. So we're going to click continue and OK. And SPSS will create a confidence interval table. And so that's right here. And here are the numbers that we want to look at. So here's our sample mean, and here's our upper bound and lower bound of the confidence interval. So we just kind of zoom in on that. We see that the mean is 13.53. So on average, people have about 13 and a half years of education. And the lower bound is 13.39, and the upper bound is 13.67. And so we can interpret that by saying that we're 95% confident that the true population mean education is between 13.39 years and 13.67 years. And notice also that there's a standard error estimate of 0.07. And so that's another thing that SPSS provides for us. Let's say that we wanted to create a wider interval to be more confident. Well, we can just change the default 95% confidence interval to a 99% confidence interval. So if we go to Analyze, Descriptive Statistics, and Explore, and we just click on Statistics, we can just change this from 95 to 99. And then if we click Continue and OK, SPSS will create another set of results for the 99% confidence interval. So here is our mean value, the same one we had before. Here's the lower bound of the confidence interval. Here's the upper bound. And again, the same standard error. And so this time we have a value of 13.35 to 13.71. And so we can say that we're 99% confident that the true population mean education is between 13.35 years and 13.71 years. And so notice that this value is just a little bit, these values are a little bit wider than their last interval. If we scroll back up, recall that the numbers that we had last time were between 13.39 and 13.67. This time again we have values between 13.35 and 13.71. So this interval is slightly wider. Therefore, we're a little more confident that we're capturing the true value of the population mean. However, the sample size is fairly large in this case. We're dealing with a sample of 1,974 cases. And so the gain in the size of the confidence interval is pretty negligible because we have a fairly large sample size. And so making a wider interval, although we have a little bit of a loss of precision, is pretty negligible in this case because the sample size is large. So advancing this detailed example forward just a little bit, suppose that we wanted to create a confidence interval for a nominal or an ordinal variable. How would we do that? Well, using the mean would be inappropriate for those variables because of their level of measurement. But if we turn one of the categories of the variable into a proportion, we can create a confidence interval for proportions. And so that's going to be our strategy. So let's say that we want to take the variable sex, and we wanted to figure out from that variable what proportion in the population are male. What we could do is we could take sex and create a dummy variable equal to 1 for men and 0 for everybody else. And so the first thing we have to do is we have to go to Utilities Variables to figure out the coding of the existing variable. And so if we go here to where it says variable and we find sex, we see that it has the following coding. So 1 is male and 2 is female. And so to recode it, we have to make a new variable. And to do that, we just go to Transform into a different variable. Now, it's important to recode it into a different variable, not into the same variable, because we don't want to overwrite the existing variable. So we have it in the future if we ever need it. And so we'll hit recode into a different variable. And we're going to have to find our input variable. So again, our input variable is going to be sex. And now we have to give a name to our new variable. Let's call our new variable male. And let's label it R for the respondent is male. and we hit change, and we notice that up here sex is equal to male now. Now we're going to click old and new values. This is where we assign old values of the old variable to the values of the new variable. And so again, our goal here is to take and recode sex, which is coded 1 male and 2 female, into a new variable that's coded 1 male and 0 everybody else. And so this is where you take the old value of the variable. Let's say that we wanted to code the old value 1 into the new value 1. And this is where you put new values, and we're going to hit add. And so basically what we're doing is we're saying that anybody who's coded 1 on the old variable, that was men, is going to be coded 1 on the new variable, again men. Now here's where we make a change. Remember that women were coded 2 on the old variable. We're going to code them to 0 in the new variable, and we're going to hit add. And now all the other variables, we basically just want to code them as missing, because really the only ones that are appropriate here are 1 and 2, male and female. And so we're going to take all other variables, and we're going to hit the radio button next to that, and we're going to code them into system missing. And so we're going to click add. And so this is our recode logic. So we're going to hit continue, and then OK. And then what we should find is that we have a new variable in our data set. And so let's say that we want to look at the frequency distribution for that variable. So if we go to Analyze, Descriptive Statistics, and Frequencies, this variable should be at the end of our variable list. So notice here that we have male. I'm going to move that over to the variables, and I'm going to click OK. And we can just look at the frequency distribution to make sure that this was coded correctly. Okay, and so here we find that we have a new variable coded 0, 1. So 1s are going to be males, 0 is going to be females. And we have 886 males, 1,088 females. And we have 44.9% who are male. So roughly about 45% who are male. That's going to be our sample proportion. So now we're going to use that variable to create a confidence interval. So again, we're just going to go to Analyze, Descriptive Statistics, and Explore. And this time, instead of using education, we'll just put that back in our variable list. We'll go to the end and find our new variable, male, and we'll move that here to the dependent list. And then we can click on Statistics, and if we wanted to, we can change this back to the default, 95%. So we'll hit Continue, and we'll hit OK, and SPSS will create a confidence interval for us. So we just have to scroll down to the end. Here it is up here. Let me just zoom in on this. So notice that we have a mean, and this is the mean of our dummy variable, which is basically a proportion. So this is the proportion of people in the sample who are male. And it gives us a standard error and a lower bound and an upper bound of our confidence interval. So let's kind of zoom in here and take a closer look at it. And so we see that our sample proportion in this case is 44.88. Here's our standard error, 0.01 approximately. Our lower bound is 0.426, let's say 0.43 if we round it. And our upper bound is 0.47. And so how do we interpret that? Well, this is a 95% confidence interval, so we can basically say that we're 95% certain that the true population proportion male is between about 43% to 47%. And that's basically the answer to that question. So, unfortunately, PSPP doesn't seem to have the capability of doing these kinds of confidence intervals, at least not at this time. And so you're probably better off using SPSS instead of PSPP to do these exercises.